Okay, I'll talk about quantities in physics. In math, we have quantities just like x, y, z. These quantities have no means it's just samples. But in physics, we have some quantities with some samples just like x or d, which have the meaning of length measured in meter. And we have, for example, a quantity named m, which is the mass mostly, and the quantity named t, which is the time. In physics, first I will talk about this table, which has 7 fundamental quantities in the SI unit system. Fundamental means that we cannot derive these quantities from any other quantity. They are basic or fundamental quantities. Add to the length and the mass and the time quantities, the temperature, which is measured by Kelvin, the number of particles, which is measured by mole, and the electric current, which is measured by ampere, and luminosity, which is measured by candela. Now, in mechanics course, we need to focus on these three fundamental quantities, which are the length, the mass, and the time, which are measured by meter, by kilogram, by second. As we see here, we have different ways to say or to represent or to measure the length. The same here, we have many ways to measure the mass. We have the pound also. Also in time quantity, we can measure it in using the year, the day, hour, minute, and so on. We will learn how to convert from unit to another unit in the next videos. Now, in the next slide, I will talk about not the fundamental but the derived quantities. If we look here, we will use again the main three quantities, which are the length, the mass, and the time. These are fundamental quantities. We can derive, for example, from the length, just the length, we can derive the area. If we have, for example, a square with dimensions x and y, measured by meter, for example, then the area of this square is x by y, and their units are meter multiplied by meter, which is meter square, as you see here. Or in general, it's a length unit square. So the dimension or the quantities of this quantity are dimensions, which are length L square. This is the dimension of the area. What about the volume? Its length cubed, as you see here, because if we have a cube and we need to measure the volume of that cube, we have x, y, and z. X, y, z, which is a length cubed, as we see here, and the unit will be a unit of length cubed, not squared, I'm sorry. Now for the speed, here we can use two different quantities. Here we use just the length to reach the volume or the area, but we can use two different quantities, for example the time and the length, to find the speed, which is a scalar. We will talk about this, or maybe hear about scalar and vector, and the velocity is the vector quantity of speed. Now the law, the formula of the speed, assume it is s is equal to v, for example, is equal to x over t. X is a length quantity and t is a time quantity. Now the dimension, we mean by the dimension of the speed is the dimension of the quantities that we derive the speed from it, which is the dimension of length divided by the dimension of the time, which is time. Okay, and the units, if you need to talk about the unit of the speed, it's meter per second, as you see here, and we can measure it by mile per hour, kilometer per hour, and so on. The same we will deal with the force. The force from Newton's second law is equal to m multiplied by the acceleration. M is the mass, which is a fundamental quantity, but the acceleration is derived quantity, which is a velocity over a time, over average velocity over a period of time. So we have the mass quantity is mass, and the acceleration has dimension of length over square time, and the unit will be kilogram meter per square second. The unit of the force is Newton, after Isaac Newton, as we know. The pressure is a derived quantity. It is derived from the force. The pressure formula is equal to the force divided by the area, which is derived quantities. So this quantity, the force dimension, if we need to talk about dimensions, so it's a dimension of force divided by the dimension of area. The dimension of the force, we know it from here. The dimension of area, this is it, and so on. Also the same for energy. The energy is, let us talk about the work, which has the same dimension as the energy, which is equal to the force multiplied by the distance. Okay, so its dimension is dimension of the force multiplied by the dimension of the length, and that's it.